Hey guys, welcome back to the shop. So today's project, friend of mine gave me this motor. He said it was good, but it has noisy bearings. And I've got a project coming up that I'm going to need this motor for. So let's do a bearing change, and also let's check it electrically to make sure or try to confirm that it is okay electrically. So let me bring you in a little bit closer and we'll get started on it. All right, so taking a look at the nameplate, this is a three-phase, 200 volt, 3 horsepower, 60 hertz, 1765 RPM. And one nice thing, and this is like 50/50 on motors, they actually have the bearing numbers right on the nameplate. So that saves time. I was able to pre-order the bearings ahead of time. It is also a high efficiency motor, and I was looking, sometimes they'll have a sticker that'll say it's inverter ready or inverter rated. Doesn't have that sticker, but most of the time when it's a high efficiency motor, they're usually inverter rated. So this is a single voltage motor. So the wiring is very simple. It's only got 3 leads. So there's nothing to get confused about here. So we're going to start with just a standard VOM meter. I've got it on the ohm scale, and it's auto ranging right now, but it's on the Megohm scale, so the highest reading it has. And I like to check the ground first, and it doesn't matter whether you use positive or negative, but put one of your leads on a good clean solid ground. And then it's important that you're not touching the wire when you're taking the reading. Alligator clips are the way to go. If all you have are just a probe type, make sure you hold your wire by the insulated part of the wire so that your fingers aren't making contact with the wire, because you'll get a false reading. And of course, there's no power, there's no wires connected, blah, blah, blah. Okay. All right, so here we go. We're going to hook up. There we go. Everything's just floating in air here. Now you notice we got a bit of a reading to start with. That's typical on a good motor. Because it'll function like a capacitor, so it'll draw a little bit of current, showing some resistance until the voltage equalizes. So what you want is it to go back and read infinity like it is right now. So we have no conductivity to ground, and you can check all 3 leads if you want, but they're connected internally inside the motor. At least on this particular type of motor. If you're not sure, just check all the leads. You should get nothing at all to ground. So this is a good sign right here. Next thing I'm going to do is I'm going to go phase to phase on our motor leads. Now if you've got a multi-voltage motor, you may have to reconfigure your wiring so that it's in a normal condition. Okay, so phase to phase, I'm on T1 to T2, just under 1 ohm, okay, and then let's go T1 to T3, roughly the same thing. So now I got to move the other wire, so now we're T2 to T3, and just make sure nothing's touching each other. Oh, that's interesting. Make sure I got a good connection here. Ah, there we go. Okay.
Try narration. So you just want to look for a consistent reading between your windings. If you end up finding one that's showing open with the OL reading, that could be a sign of a bad motor. May also be just wired wrong, so just double check all your wiring. But you're just looking for consistency here between the windings. Okay, let's move on.
All right, so I've got my Megohmmeter set up, and this is just a cheap one, but it is a Megohmmeter. The difference between a Megohmmeter or Megohmmeter and a regular ohm meter is this sends out a much higher voltage. In fact, this one is a 500 volt They do make them in higher voltages. This is just a straight 500 volt. So when you're taking your reading, it's actually using 500 volts on whatever it is that you're testing. So you want to be careful that you don't touch any of your leads. I'm going to use this little clip lead again. I've already got our ground hooked up. Let's see if that will stay on there. Okay, everything's floating free, nothing's touching. Okay, we're going to go megohm scale and megohm on. Okay, here we go. Give it a few seconds. So we got 50. So we got 50 megohms. That's not the greatest. It's actually okay because this motor has just been sitting in an unheated garage, and it was sitting outside for quite a while. So you will get a lower reading when the motor's been around moisture, okay? All right, I'm going to shut it off. Ideally, we would want it, up in the 100 to 500 or even 1,000 megohms. Okay, just going to mark the end bell and the motor case. Got 2 here and 1 there, so we know which end goes where. Some motors will have a bearing retainer flange on the back side of the end bell, and you'll have a couple bolts through the front that you got to take out first. Looks like the back end is coming out first. All right. Yeah, you guys are right in the way. Be careful not to drag on the windings. Okay. Oh yeah, we'll clean that rust off. Like I say, this thing was sitting outside for quite a while. There we go. Okay. So these are open. The ends are open. The back sides have a metal shield. What I bought are rubber sealed bearings, and I've done a lot of motor bearings, and the rubber sealed seems to be the least amount of trouble. You put them in, and you don't do anything. You don't grease them, nothing. Just leave them the way they are. Okay. All right, well, let me clean a little bit of that rust off, and then we'll get a puller. Okay, so this is actually pretty common for a motor that sits in an unheated, kind of damp environment. Like I say, this one was stored outside. It was covered, but it was outdoors. So there's enough mass in an electric motor that overnight it'll get really cold, and then during the daytime when things warm up, if there's a lot of moisture in the air, you'll get condensation forming on all these surfaces, and you'll get rust. Look at the rotor; it's got quite a bit on it. So I'm just going to give all this a light wire brushing just to knock that off. And that's probably the other reason we were getting a lower megohm reading. There's probably some moisture in these windings as well. Okay. Now let's look at these bearings for a second. So the way this is not unusual, but less common to see this type of a setup where you have one side of the bearing is open, and then the back side is shielded, and then your housing has your grease ports, and you can tell this has never been greased. That's the grease from the factory just sitting in there. Okay. I know in my opinion, you're better off not going this way. You're better off with a sealed bearing. Just leave it alone. But if you have an open one like this, what you're supposed to do you see there's two ports. So the bottom one, this would be the bottom, you take the bottom one out, and you do this when the motor's warm, after it's been running for a good period of time. Take the bottom one out, put a grease fitting in the top one, and you pump in several pumps of grease. Leave this one out and run the motor for several hours with this plug out. That lets the excess grease that becomes pressurized while it's running escape out, and then you shut it down, you put your plug back in. That's the right way to grease it. If you just pump grease in without opening the vent port, you're going to overfill it with grease. The grease has got to go somewhere. It'll get inside the motor, and it ends up getting on your windings, and over time that's going to degrade your insulation and most likely lead to a motor failure. Yeah, we've tried everything, and the best we've found is get rubber seal bearings. They already have the right amount of grease in them, usually a quality grease, as long as you're not buying the Chinese bearings. And just put them in and leave them alone. Plug your grease fittings and just never touch it again is in my opinion their best bet. Oh, well, what I forgot to say that was unusual is the fact that they actually had removed or used a bearing with an open, unshielded on this side, which corresponds to the grease cavity here. Most of the time, you'll find that it'll have the grease cavity like this, but they'll have the shield installed on the bearing. So other than a little bit of airspace that's around that metal shield, there's really no way for the grease to get into the bearing. And it seems like it's more common to find that than ones like this that are actually open and exposed where the grease could actually get into them. A lot of your heavy duty motors or larger motors will have a lock nut or sometimes a collar, an extra pressed on collar to hold the bearing on. But in most cases, on your standard motors, say under 20 horsepower, it's just a press-on fit. Okay, and I'm going to try to do this without using the hydraulic press. So that way, if you're doing one of these and you don't have access to a press, you can still do it. Back that way out. There we go. Okay. Right, so off camera, I'm going to clean up some of this rust. Avoid the temptation of hitting these bearing mounting surfaces with any emery cloth. You don't want to do anything that's going to affect that press-on fit. If there's corrosion that you need to clean off, just a little bit of Scotch-Brite, just do the minimum, maybe a little bit of WD and some Scotch-Brite. Don't sand them, okay? All right, let me get this cleaned up and then we'll put the bearings on. All right, so off camera, I wire brushed all the rustiness that was on here. And same thing on the inside of our stator. The stator wasn't bad. And then I just wiped it down with some WD, so that hopefully it won't rust in the future. So we're ready to put the bearings on. We're going to use the bearing warmer method of installing the bearings. You could press them on, but a lot of guys don't have a press, so I want to show you how to do it this way. This is my poor man's bearing warmer. I've been doing it this way for many years. Just a drop light with an old school incandescent lamp. That's a rough surface lamp. It's actually got like a rubber coating on it, so it won't shatter if you break it. and I think it's a 60 watt. So I just take my bearing, I've already checked it, it's clean. I just set it right on the light bulb like that and let it warm up. And to speed things up, if you cover it with a rag carefully, it'll warm up a lot faster. Okay, we'll let that warm for a minute. You're going to need a pair of gloves to handle that bearing once it gets up to temperature. Okay, so while we're waiting for that bearing to warm up, so you can just press these on, but you'll need a piece of tubing for a sleeve that would make contact with the inner race. You could probably use a shorter one like this, but then you'd have to put it in some V-blocks in your hydraulic press. And I got a small one here for the other bearing. Hopefully we won't need these, it'll just go on with the heat. The way I check them is if you can still pick it up with your bare hand, it's not hot enough. You're looking for about 200 degrees. And obviously you don't want to overheat it. Okay, I think we're there. If you've got the style that has a retainer plate that goes behind the bearing, make sure you put that on first.
Alright, let's see what kind of luck we have here.
And there's no direction on these type of bearings, so it doesn't matter which way it goes. This is just a standard deep groove. There we go. And then I always like to just kind of hold it all the way back because as the bearing cools, it does shrink a little. On a small one like this, not really going to matter, but on a very large bearing, it can actually shrink back and leave a thousandth or so gap behind the bearing. All right, let's turn it around and we'll do the back one. I've got our other one heating up. Yeah, that didn't take long at all. That was maybe 3, maybe 4 minutes on the light bulb is all it took to get it hot enough to expand and slide on there. Okay, I think this one's ready. Maybe not. Okay, we're going to heat that one just a little bit more. If it doesn't go right away, just take it back off and let it warm up a little bit more. Okay, let's try this again. There we go. Much better. And just like the other one, you want to just check it every few seconds, kind of make sure it stays pushed up against the shoulder. Okay, we're ready for reassembly. Bearings are on there nicely, feels good. Slip the rotor in. Being very careful not to nick those windings. Back end bell. Now they do have a little spring wave washer on the rear end bell. Make sure you get that in there. I put a little dab of grease on the corners just so it doesn't fall out. If you try to draw them in with the bolts, you got to be careful. You might catch the edge. It might not be lined up correctly. And you can, do some damage trying to draw it together that way. Okay, well that's pretty much it. All right, well that's how you change bearings on a basic three-phase electric motor. What I will do is I'll mark on here somewhere that these bearings are sealed so that nobody tries to grease them in the future. So there we go. We'll test run this on a different video. I've got something coming up for that. And then I've got a project coming up where I actually need to use this motor on a piece of equipment. Okay, thanks guys, and we will see you soon. Thanks for stopping by.